All right, going to have everything off your desk except for a pencil and your speed drill booklet. We're going to go ahead and get started with a speed drill today. Speed drill 23. Speed drill 23. So quickly passing those back, Jalen. Actually, give me Michael's. Off the bottom, I believe. All right, Michael, if you're watching, hope you get feeling better soon. Missed you Friday, missing you again today. Speed drill 23, so open up your booklets there. Quick reminder that the word of class means multiply. And we can't really multiply a percent. We have to turn it into a decimal. But how many places do we have to move the decimal before we can multiply?
2.
2 decimal places. Also remember, if you have zeros, that can knock off decimal places. There's that little bit of a shortcut. If you're looking for something more straightforward, the bottom row is a little more straightforward. Just be careful with your decimals. Remember, when you multiply decimals, your answer needs to have as many decimal places as you see in the original problem. You're going to have 4 minutes for this speed drill, and you may begin. Stop. Put down your pencil, get out your pen. Pencil away, pen out. And exchange with the person behind you, person in the back, bring yours to the front. Pencils away, pens out. And in pen, pencils off your desks. In pen, assign your name as the grader. Next to where it says Speed Test 24. In pen, assign your name next to where it says Speed Test 24. Again, pencils should be off your desks. These are going to be 12 points each. 12 points each. Number one, 12% of 1,250 is 150. 150. For number two, 125% of 62 is 77.5, or 77.50 is fine also. Number three, 8 3/4% of 9,000 is 787.5. 787.5. Or if they had 787.5000, that's fine, of course. Number four, should have had 3 decimal places in the answer. We get 1.624. 1.624. For number 5, 2 decimal places in the answer, 160.17. 160.17. For number 6, we need 5 decimal places, 0.00387. 0.00387. For number 7, we needed 2 decimal places, 130.64. 130.64. Nice earrings, that's random, but I heard them jingling. Little Christmas trees with bells. All right, anyway, 130.64. I'm not ADD or anything. Number 8, 2 decimal places also, 4,714.08. 4,714.08. All right, they're 12 points each, so multiply total number wrong times 12, subtract from 100, put the score in the score blank, and then also flip back to that first page. Make sure you put it next to where it says Speed Drill 23, just 4 more in the rest of this quarter. So put next to Speed Drill 23, 12 points each. So minus 0, 100, minus 1 is an 88, minus 2 is a 76, minus 3 is a 64. If it's more than that, figure it out yourself because I don't want to have to say it. Put the score in the score blank, return to the owner, and let's see, hurry up and pass things back. Were there any hundreds? This was a tough one, especially on a Monday morning. Corey, 100, outstanding. Any 88s? You just missed 1. Couple of you, good. 76s, that's still pretty good. I know that's not a great grade, but I think on this one that's a pretty respectable job. 76s? All right, any questions? Pass them. Yes, ma'am. Number 3 was 787.5. Do you need to see that one worked? No? All right. Any questions? Pass them in. And have your desk cleared for now. Just keep your desk cleared for now. You do have a test in our next lesson, lesson 75. We'll want to spend a little time reviewing. Actually, we'll spend the whole hour reviewing for that test. But let's go ahead and start with some flashcards. For sake of time, we won't have time for a flashcard game, I'm afraid. And I want to make sure that we're able to get this on camera as well for Michael and for Evie. So just call out what we've got here, class. These 2 angles are adjacent because they have a common vertex and they share a side between them. This is a right triangle, more specifically, because it has a right angle in it. This is an
equilateral.
Now, you're not wrong, Ben. It is isosceles, but more specifically, the better answer is equilateral because all the sides are marked as being equal. These lines form vertical angles. Specifically, angle 3, class, would equal angle 1. Good. This is a rhombus. You say, oh, it's a parallelogram. Yeah, but the sides are equal, so we call it a rhombus. What would be the name of this angle? Angle Y is the easiest way. We could say X, Y, Z. We could say Z, Y, X. But just angle Y is the easy way to say it. These triangles are congruent because they're the exact same shape and same size as well. These angles are complementary because they add up, class, to 90 degrees. This is an acute angle. This is an octagon. 8 sides. It's a stop sign. This is a reflex angle. These lines are parallel. Don't forget the symbol for parallel is that 11 looking thing, but stretched out a little bit, skinnier, closer together. This is a group of different Polygons, because they're all bounded by straight lines, more specifically, right? This is a point, an exact location in space. We name it with a capital letter. This is a heptagon. It's a heptagon. It's got 7 sides on it, a heptagon. This is a rectangle. Yes, ma'am, question?
Do we have to know the heptagon for a quiz or something?
Why not? All right. This is a square. Has one end point, then goes infinitely. Is a ray. Good. Obtuse angle. Good, Sam. Line segment is just a portion of a line. Hexagon. 6 sides is a hexagon. These 2 triangles are similar. They're the same shape, but they are not the same size. These lines are perpendicular because they form right angles. They're perpendicular. Remember the symbol for perpendicular is that upside down T. But they're perpendicular because they make right angles with each other. Speaking of which, right angle. These angles are supplementary because they add up to 180 degrees. This is a straight angle because it is 180 degrees. Pentagon, 5 sides. Line because it goes infinitely in both directions. Specifically an isosceles triangle. Ben, make sure you're looking up this way. This one, it can't be called equilateral, but it is isosceles. 2 of the sides are equal. Parallelogram. Opposite sides parallel, but trapezoid because only 2 sides parallel, the other 2 are not. So a lot of things to keep track of. As well as, of course, the circle stuff we've talked about more recently. Page 175 in your textbooks. This homework has a lot of good review for us. A lot of good review for us that we need for the test coming up tomorrow. Textbooks open at page 175. Should have also had a couple different drawings of some circles that you were supposed to have. So have that out as well. And let's take a look at the homework. Number 1 on page 175. Page 175. There we go. Now I can see all the homework. Good. Ask this, if angle 1 and angle 2 are vertical angles, where's the drawings? Are they on a separate paper? You didn't see it, it's right there. How'd you not see it after you did number 12?
I don't know.
Get a piece of paper out. Good. If angle 1 and angle 2 are vertical angles, and angle 1 is 64 degrees, what is the measure of angle 2, Elaine?
I see where you are. 64 degrees?
Yeah, like number 1 on the homework. That's where we are. Page 175. Good, 64 degrees, because vertical angles, class, are always equal to each other. Vertical angles are equal. Number 2, a pentagon has the following side lengths. 5 inches, 3 inches, 7 inches, 4 inches, and 3.5 inches. It asks this, what's the perimeter of the pentagon? And how do I find perimeter? Corey?
You add it up.
Add what up?
All the inches.
Construct with a compass and a protractor. All that on paper. Yeah, no, we have to. Okay, we'll mark that on the green slip then. So we add up all the sides. What did you get for number 2, Corey?
22.5 inches.
22.5 inches is correct. Number 4, if the radius of a circle is 4.4 yards, what is the circumference? How do I find circumference of a circle, class? C equals 2 pi r, or C equals pi d. Which one do we want to use here, Griffin? On number 3.
You want to use pi to
2 pi r. There we go. We want to use 2 pi r. So we want to double that radius and then multiply by the pi, 3.14 approximately. What do we get for our answer on number 3, Griffin?
113.816.
Uh-oh, you forgot the 2. You just multiplied by pi. 2 pi r. Did you get an answer that was twice as big by any chance, Kirsten?
27.632 yards?
Well, we don't say 0.632, just 0.632.
Oh.
But yeah, approximately 27.632 yards. For number 4, the symbol notation for ray BD, you want to draw write the capital BD, and then just draw a ray over the top of it. For number 5, it says, what's the perimeter of a parallelogram with side lengths of 16 feet and 14 feet? Well, we don't exactly have a formula for the perimeter of a parallelogram, but what do we know about opposite sides of a parallelogram, Ben?
That they're both parallel.
That they're parallel. What else do we seem to notice about the lengths of these two sides and the lengths of these two sides?
It's a
Class?
They're equal.
They're equal. So if this side is 14 and this side is 16, then how big is this side, Ben? Sam?
16.
Okay, 16. And how big is this side then?
14.
14. So we couldn't just add the 14 and 16 because that's not all the way around, class. That's only 2 of the sides. I still have 2 other sides to account for. What should we have had for the perimeter on number 5? Anyone?
60 feet.
60 feet is correct. 60 feet. How many had 30 feet? Be honest. You had 30 feet. How many had the 60 feet? Excellent. Most of you thought that through very well. Good. Let's see. Number 6. What's the difference between a diameter and a chord, Sam?
The chord is half of the diameter.
Not necessarily. A radius is half a diameter.
A chord is not going through the middle of the
Chord doesn't necessarily go through the, what do we call that?
point. Center.
The center, there we go. The chord doesn't necessarily go through the center. A diameter always goes through the center. Number 7, what are 2 examples of a quadrilateral? There's a lot of things you could have put, Jalen. What are a couple quadrilaterals we've talked about?
Square and rectangle.
Square and rectangle. Anyone have something else?
Rhombus and trapezoid.
Rhombus, trapezoid. There's still one more we talked about. Parallelogram. Those are the 5 different special quadrilaterals we had discussed. You could have listed any 2 of those. Number 8, if triangle MNO has angle measurements of 50 degrees and 100 degrees, what's the measure of the third angle of a triangle MNO, Bryson?
30 degrees.
30 degrees, because the sum of the 3 angles, class, is
180.
180 degrees. We've already got 150 degrees spoken for. By the way, number 8, what type of triangle would MNO have to be? Anyone? Definitely not. Obtuse triangle, because it has an obtuse angle in it. Let's see, number 9, 4 of the 5 central angles of a circle. 44 degrees, 81 degrees, 110 degrees, 10 degrees. What's the measure of the 5th angle, Luciana? 115 degrees, because we know all of those central angles have to add up to,
360.
well, I was asking her, but you're right, 360 degrees is correct, Bryson. Number 10, what kind of triangle has all sides and angles equal? Elaine?
Equilateral.
Good, you could have put equilateral, or you could have also said
Equiangular.
equiangular, or there was another term, I don't even know if I mentioned this term to you, regular? You don't have to know that term, but a regular triangle, regular, like a square is also regular, because it's equilateral and equiangular. You don't have to know that term yet. Number 11, what kind of angle is a 215 degree angle? Corey?
Reflex.
Reflex angle. Number 12, what's the measure of all the angles in the triangle? They gave you that blue triangle. We would have probably needed to extend the sides a little bit so that we could read it better with our protractor. What did you get for angle I? Griffin?
75 degrees.
75 degrees, okay. What'd you get for angle M?
Oh, I forgot to get those.
Oh, what did you get for angle J? You only found one of
It'll
them.
be 75.
Well, it looks like it'd be about 75, which means that angle M would be around 30. The actual measures are 74 degrees for I, 74 degrees for angle J, 32 degrees for angle M, were the answers that were actually there, computer generated. But if you were within a couple degrees in each case, you're good to go. What kind of triangle does that appear to be at number 12, anyone? Isosceles triangle also does appear to be an acute triangle, but since a couple of those angles were equal, it means a couple of the sides are going to be equal, which means isosceles. Number 13, you were supposed to construct a circle using a compass and the given information. And for number 13, they told us what about our circle, Kirsten?
That it's 10 millimeters.
What is?
The radius.
The radius is 10 millimeters. And what you should have, millimeters. Ooh, those are the little ones, aren't they? My ruler doesn't measure, now it does actually have little millimeter markings, but the numbers are in centimeters, right? Well, 10 millimeters equals how many centimeters, class?
1.
Just 1, right? Go from milk to chocolate, make sure you're paying attention, Ben. Go from milk to chocolate, move the decimal one place, 10 becomes 1. So really all you needed was to measure out a single little centimeter. Now, my question is, can your compass even measure that small? Some of your compasses can. Some of your compasses, it's really hard to only open at 1 centimeter. That's really, really obnoxiously small and obnoxiously hard to draw a circle. But how many did get just a little tiny circle with a 1 centimeter radius or 10 millimeter radius? Hit questions on that. All right, for the next one, they told us what about our circle, Ben?
Number what?
Number 14, the next one.
It's 2 inches diameter.
2-inch diameter. Now, can my compass class draw a diameter?
No.
No, all it can ever draw is a radius. So Ben, if it tells me the diameter is 2 inches, I should draw
1 inch.
1 inch for my radius. So I'll go to the inch side now, and we'll draw a 1-inch radius. And then you measure that with your compass. That one's a little easier to measure. Oh, okay, there we go. And then you draw your circle, and your two circles should compare to each other like mine do. You got your little tiny one with the 10 millimeter radius, and then this would be, if I extended it out to a 2-inch diameter, would be considerably larger. How many have those two circles? Okay, any questions on drawing circles, given a radius, given a diameter, anything like that? All right, let's drop down to number 15. They wanted you to measure angle AEB. First of all, class, just look at it. What kind of angle is AEB, Sam? Not how big is it, but like what kind of angle is it? Less than a right angle? Class? Acute. We're looking at the circle, the green circle. Sam, number 15, pay attention. Angle AEB is an acute angle. So class, if I get 100-something degrees, does that make sense?
No.
No. How big, Sam, back to you, did you measure angle 15, or number 15, angle AEB to be? It is 50 degrees. How many got 50 or within a couple degrees of 50? And then the other angle they wanted was CED. Now CED almost looks like a right angle to me. Does it look like exactly a right angle to you, Jalen, or does it look a little bigger or a little smaller? But it's a little smaller. So we're looking for something that's almost 90 but not quite. When you measured it, Jalen, what was angle CED? 85 degrees. How many had 85 or within a few degrees of 85 degrees? All right, questions on 15, 16. All right, number 17. Find the circumference of the circle using the given radius or diameter. And for all of these, we really didn't. It said to use 3.14 for pi. I'll usually cheat and use 22/7 if it's convenient. It's never convenient on any of these three problems. So we'll use the 3.14 every time. Number 17, what did you get for your circumference, Bryson?
47.1 feet.
Approximately 47.1 feet. Question, Jalen. Oh, okay. Well, we're just kind of going around in order here. Good. Because on number 17, when it's a radius class, we use the formula C equals
2
pi r. Number 18, what did you get for your circumference? Luciana?
Approximately 69.08 inches.
Approximately 69.08 inches. Because class, when you're given a diameter, use the formula C equals pi d, which means we don't do any times 2ing, right? Just pi d. Number 19, if the diameter is 17 centimeters, Elaine, we get?
Approximately 53.38 centimeters.
Approximately 53.38 centimeters. Again, just multiply 3.14 by 17. How many got all three of those right? 17, 18, 19. Questions on those? All right, we're starting to recognize when do we multiply by 2, when don't we multiply the 2. Okay, make sure if it's a radius, times the 2 because 2 pi r. No radius, if it's diameter, no 2, just pi d. Number 20, we've got some intersecting lines there with some vertical angles formed. And the easiest angle to find, no math required whatsoever, Corey.
Angle 2.
Angle 2, it's got to be
112 degrees.
112 degrees. Now, what do we know, Griffin, about angle 1 and the indicated 112 degree angle?
They're adjacent.
They are adjacent. They're also going to be what kind of angle do there?
Straight angle.
It adds up to a straight angle. In other words, it adds up to
180.
180 degrees, which means they are
Supplementary.
supplementary. That's the word I was looking for. They're supplementary. So then how big is angle 1 if it's the supplement of the 112 degree angle? Bryson?
68.
68 degrees. Okay, well if this is 68, then what is angle 3, class?
68.
68 degrees also. How many got all 3 of those angles correct? Any questions on that? Remember, vertical angles are equal. The adjacent angles will be, class, supplementary. What are the adjacent angles going to be? Supplementary. Vertical angles going to be? Equal to each other. There we go. Number 21, find the perimeter of each figure. And we got a really weird looking hexagon there in number 21. And we've got a couple pairs of equal sides in the figure. What did you get for the perimeter, Kirsten? 56 meters. There's 2 11-meter sides, 2 9-meter sides, 2 8-meter sides kind of tucked inside. I don't know, kind of looks like a, I don't even know what it looks like.
A harp.
Harp, interesting. All right, number 22, we have a regular pentagon. All the sides are equal, so it's equilateral, happens to also be equiangular. But one of the sides is 8 miles. Phew, that's a big, whatever you call it, pentagon. What was the perimeter that you got on 22, Ben?
40 miles.
40 miles is correct. Questions on the homework? Any questions on homework? Again, test tomorrow. So if there's something from the homework you're still a little iffy on, you better ask now. Because tomorrow, it's too late. Questions? All right, look back across the page if you would. Page 174. I want you to do 21 and 22. Page 174. Let's practice a little bit more with that vertical angle intersecting line thing, because we had a little trouble with it. Let's make sure we shore that up for tomorrow, just in case that should show up on your test. I mean, probably will. We've done enough of them. Very likely to appear. Yes, ma'am. I believe it's 6 o'clock our time, 5 o'clock Alabama time. Once you're finished, pencil down, look this way so I know that you're finished. Take just a little longer if you're still working. All right, Sam, on number 21, they give us angle 1 is 57 degrees. Which angle is the easiest one to find?
3.
Number 3, because it's 57 degrees also. No math required. But angle 2. All right, here we go, Griffin. How big is it?
123 degrees.
There we go. 123 degrees is correct. Number 22, they give us angle 4 is a, it doesn't look like it. Angle 4 is an acute angle. It can't be 103 degrees, but it's okay. We'll just take their numbers. If angle 4 really were 103 degrees, then Jalen, what other angle would have to be 103 degrees? On number 22, if angle 4 is 103, what other angle is 103?
6.
Angle 6. What is angle 5 going to be then, Jalen? 77 degrees is correct. Questions on those? How many got all those answers correct? All right, we good to go on that? Get out your protractor and some blank paper. You can set your, you might be able to do this with your book on your desk, but you may need to set the book on the floor. It's up to you. I want you to do 23 to 25. Just draw the angles with your protractor. Just draw the angles 23 through 25 with your protractor. So you got a 12-degree angle called ABC, got a 65-degree angle called XYZ, and a 120-degree angle, which we're calling QRS. Protractor out, and draw those 3 angles on your paper. Got it? When you're finished, check your angles, make sure they look like mine. Say, yep, mine looks like his, you're good. You don't necessarily have to put the arrows at the ends because, again, line segments can form angles just as well as rays can. If you want to make them rays with the arrows, that's fine. If you want to make them line segments by not putting the arrows, that's fine also. Of course, which letter will get to be the vertex, class?
B.
Well, in the first one, B, but in general, it's the middle letter, right? Whatever letter's in the middle is how you label your vertex in each case. Really, the other two are interchangeable. I said X at the top, Y, and then Z here at the bottom. I could have put the X down here and the Z up here, and it still would have been the same thing. So as long as the middle letter is your vertex, the lettering isn't necessarily that important. Any questions on drawing angles with the protractor? We all feel good about that?
Yes.
Now I want you to construct an angle equal to XYZ. So get your compass out and construct an angle that is equal to XYZ. Construct an angle that is equal to XYZ. And for this, you may want to get your book off your desk. Obviously, the book won't be an issue tomorrow, as it will not be on your desk anyway. Just looking out for you, trying to help. Remember, you start by drawing a line, kind of like X or YX, line down here. Then, class, you'll take your compass and make an arc. Not arch with an H, just A-R-C, arc, that goes across both sides. Where does the point of the compass need to go?
Vertex.
On the vertex. So put the point on the vertex, make that arc. Then don't close the compass, remember, and put the point at one end point here and make another arc. Then what's the next key? We make arcs that are the same size, and then we make sure they're actually the same size by...
Connecting the dot. No,
Well,
never mind.
Not yet.
Measuring the arc.
Measuring between these 2 points. So if I call this point A and this point B, you don't have to name them, but then I'll measure how far apart A and B are, and we'll get that measurement with our compass. Come over here, make that same measurement, and now we get to connect the dots. How many did this construction there at your seats? You have another 65-degree angle, but you constructed this one this time. All right, any questions on constructing an angle? Any questions on constructing an angle? While you've got your compass and protractor out, let's have you, or your compass out at least, let me have you go ahead and draw 2 circles. You're looking at 26 and 27, an 8-centimeter diameter, and another circle with a 3.5 centimeter radius. All All right, so draw two circles on your paper. These happen to be 26 and 27. They don't need to look in your book necessarily. Diameter 8 centimeters and radius 3.5 centimeters. Yes, ma'am. Rent or borrow? Do you have 25 cents? Okay, see me after class. Make sure you have your compasses and protractors tomorrow.
Seriously.
If it says the diameter is 8 centimeters, do I need to open up my compass 8 centimeters?
No.
No, class, I just open it
4
4 centimeters. Make sure you measure off 4 centimeters. Measure that 4 centimeter line and make your circle. If it says the radius is 3.5 centimeters, do I need to measure out 3.5 centimeters, class?
Yes.
Yes, I do actually need to measure out 3.5 centimeters. Make sure your ruler or whatever you're using, many of you have a protractor, but make sure it has centimeter markings tomorrow. It's not a huge difference in how much your compass is going to be open. So we see, very similar radii, so very similarly sized circles. Second one's just a little smaller than the first one. Question?
So, on the first one, it's 3.5, so it's half a centimeter.
Half a centimeter smaller, yeah.
So, is that okay? I do.
You drew them concentric is the term for it. She drew them where they both had the center at the same point, so one's just inside the other one. Yes, technically you can.
That's space.
Yeah. Now, if on the test tomorrow there's a question asked for one and then later there's another question, make sure you do them in their own separate spots, but yes. All right? Yes, ma'am.
We also have rulers if our
Yeah, if your protractor has inches and centimeters on it, you don't have to have a separate ruler, no. Just make sure that whatever you have tomorrow for the test, you have centimeters available to you in case the test asks for them. Questions on that? All right, get your books back out, put them back on your desk, and do numbers 29 and 30. Number 29 and number 30. Go ahead and measure a couple of those central angles. Go ahead and measure a couple of those central angles. Remember, a central angle is an angle formed by two
diameters?
not two diameters, two radii. There we go. A central angle, class, is formed by two radii. And where's the vertex?
The center.
At the center, hence the term central angle. So central angles you see there on page 174, numbers 29 and 30. Do you have a quarter? I got a little one this time, but it actually fits on your book better. So measure those two indicated central angles, XWY and ZWY. if I call these angles 1, 2, 3, and 4, which of these, class, is XWY? Angle 4. So make sure the first angle you measured was this one here. How many? That was the angle you identified. XWY. Make sure you look at the 3 letters. How big was XWY, Luciana?
35 degrees.
I'm sorry?
35 degrees.
35 degrees. Well, wait a second, Luciana. This looks like an obtuse angle.
Oh.
Uh-oh, you fell into the trap. Hey, better to make that mistake today than tomorrow, though, right? Think about what you're saying. It's an obtuse angle. You better pick the big one, not the little one. So if your compass is, or your protractor is saying 35, you want to look at the other scale, which means you want to say it's
150 degrees.
not quite 150,
145.
145 degrees. Should have had 145 degrees. You were almost within the margin of error, minus a point. All right, and then the next one is ZWY. Class, which of these, 1, 2, or 3, is ZWY?
3.
Angle 3. So for your second angle, you should have measured the one that was right here. And how big was that angle for redemption, Luciana?
80 degrees.
Almost 80. The book says it's 78 degrees, but you're within the 2 degrees, no points off. How many had 78 or within a couple points? Maybe said 80 also, because that was the whole number that was close to it. Questions on measuring angles? Any questions on measuring angles? Let's see, we don't have a lot of time here. Let's do numbers 32 and 33. Do 32 and 33 at your seats as we round out the hour. One last chance to practice finding circumference given radius or diameter. (32 and 33). Yes, sir.
So on the radius, you have to double.
What's the 2 formulas we're using here, class? C equals
2 pi
2
r.
pi r. So if you're given a radius, double, because the 2 is there. If you're given a diameter, class, we use C equals
Pi d.
pi d. So if you're given a diameter, there's not a 2. Don't worry about the 2. Yeah, Brecken drew it. And Noah helped him put more snowflakes in. So Brecken drew the original snowflakes, and then Noah added the math symbol snowflakes to make it a math snow globe to go with my math tree.
Oh. Oh, wow. Did he use a compass?
No, he drew it freehand.
Wow.
The circle was just drawn freehand, and after he drew the circle, I was like, you should turn it into a snow globe. So he did.
How did he have good
Using P. Using P.
It was right while the guys were changing for P. He just drew a big circle. Yes, sir.
Got a hole in it.
It does at the bottom. All the snow's going to fall out. It wasn't a perfect circle, but it was close. It was really good. It was good enough to turn into a snow globe. Anyway, we're working on 32 and 33, so we can be done before the bell rings. Right?
Yeah. Yes. No.
Just put a little higher. Just kidding. Don't actually. All right, number 32. Multiply 15 times 3.14. What do we get for that circumference? Bryson, number 32?
Approximately 47.1 degrees.
Oh, the
No.
feet.
The feet.
Feet, there we go, approximately. Remember the approximately, just forgot the feet. Approximately 47.1 feet. And if the radius is 8 inches, Kirsten?
Then you want the answer?
Yes.
Okay.
She did that just to make me go past the bell.
50.24. Feet, inches.
Approximately 50.24 inches. Remember, we have to multiply by 2 to get 16, then multiply by the pi. Approximately 50.24 inches. No homework this evening, other than I would take a moment in study hall or when you get home tonight or even first thing in the morning, especially if you feel like you're doing pretty well with this chapter, skim through chapter 4. Just skim through, look at the bold terms, look at the pictures, the example problems real quick. Refresh your memory at some point, either study hall tonight or tomorrow morning before you take the test. All right, you are dismissed. Have a wonderful rest of your day.